Hello, mathematicians, and welcome to another lesson. I am Mr. Garcia, and today we're going to be talking about 3D shapes. So this is lesson 7.4, an introduction to 3D shapes. So let's start with our objective today. I can identify various 3D shapes and categorize them as prisms, pyramids, cones, cylinders, or spheres. So why don't we start by defining what it means to be 3D. So 3D, we know, means that it has three dimensions now: length, width, and height or depth. You might see height, you might see depth, but those are your options here. So we're not just restricted to a flat plane anymore. Remember, 2D shapes, we only had the length and the width. But now that we have height or depth, that adds that third dimension and makes existence in the real world possible. Now, when we look at a shape, a 3D shape on a window or a screen or a sheet of paper, for example, this cube here, we know this is not actually 3D because we can't touch it, we can't take it out, we can't move it around. This is only a projection of a cube. So while the shape itself is three-dimensional and it's the cube, what we actually see here is a projection of that cube. The projection means that it's a 2D representation of a 3D shape. So technically, everything that you're going to see in this lesson are projections, except once we get into the demonstration part. But everything that you see on this flip chart are projections of 3D shapes. If this was actually 3D, you would be able to reach to your computer screen and take the shape out, look at it, move it around, whatever. But that's what that means. So projection just means you're seeing that 3D shape, but it's on a screen or on a sheet of paper or on your monitor like you're looking at right now. That's what it means. Now, 3D shapes can be categorized into 5 groups: prisms, cylinders, pyramids, cones, and spheres. In addition to these categories, prisms and pyramids can also be named polyhedrons. So the way to think about polyhedrons is to remember polygons. So if you remember polygons that we talked about, and let's say that I have polygons, we know that a polygon is any 2D shape that has sides, basically. So for example, that is a polygon, is a pentagon, because I have 1, 2, 3, 4, 5 sides. Now, the same way that we can name polygons according to their number of sides, polyhedrons can be named according to the number of faces that they have. For example, tetrahedrons, we remember that the word tetra means 4. So a tetrahedron means a 3D shape with 4 faces. A hexahedron means that it has 6 faces. And a dodecahedron, dodeca meaning 12, means that this shape has 12 faces. Now, this only applies to prisms and to pyramids, so keep that in mind. So let's start our exploration of 3D shapes with the prisms. Now, we see the names of the prisms up here. I want to explain how we got those names right now. The bases of a prism are a set of parallel faces across from each other that are some kind of polygon. So for example, if we look at this first one, it's named a triangular prism. Now look at this though, and you see that the front face here is a triangle. The face across from that, if I were to line this in here, you see that this face would also be a triangle. So these two are my bases. Those are the bases of this prism. And because the base is a triangle, we call it a triangular prism. If my base is a square, then it's a square prism. My base is a rectangle, rectangular prism. If my base is a pentagon, 1, 2, 3, 4, 5 sides, then it's a pentagonal prism. 6-sided base here, hexagonal prism, and 8 sides on the base is an octagonal prism. So those are my bases. Now the other sides that we have, the other faces we have, are the lateral faces. And the lateral faces are always going to be rectangles, which are perpendicular to the bases. So here, for example, in my triangular prism here, my base here is a triangle in red, but the lateral face here in blue is always a rectangle. So behind this, I have another triangle back here. And if I join these two, then I can see the back, and I see that my other base would also be a triangle. Now, there is one type of prism that isn't really a prism. Let's talk about that. Cylinders have the same properties as prisms, but take a look at this. If the bases of a prism are circles, then the shape is not a prism. Instead, it's called a cylinder. So this looks like a prism, kind of, except instead of a polygon as the base, we have a circle as a base. And because we have a circle, circles, they don't have edges. So we can't have any lateral faces. Instead, we have the lateral surface, which, like I said, has no edges, no faces. It's just a smooth, round surface. So that's the difference between prisms and cylinders. Don't ever call a cylinder a prism, because it's not. It has the same properties as a prism, but it's not a prism. Let's go to Mr. Garcia so he can show us what some of these shapes look like in real life. Has the same properties as a pyramid, except the base is a circle and we no longer have lateral faces. Instead, we only have one lateral surface with no edges, no faces. So here, for example, I have my base at the bottom. My lateral surface is this part right here that makes up the body of the cone. And the apex, again, is this point at the very top. Now, obviously, we don't have triangles joining here, so I just like to call it the pointy end of the cone. But the apex is always across from the base, too. So wherever the apex is, the base is across from it. Let's go to Mr. Garcia now to show us some pyramids and some cones. All right, so let's take a look at some more 3D shapes. Now we're going to be looking at pyramids and cones. So let's start with this one. If I want to figure out what to name this, I have to decide which one's going to be my base. Now, because all of my faces here are all triangles, that means that I can choose whichever one to be my base. So if I choose that one to be my base, now I see that I have my lateral faces along the sides. And as we said in the lesson, these are all triangles. So my lateral faces are always triangles. My base is going to be some kind of polygon. In this case, my polygon is a triangle. So that makes this a triangular pyramid. We know that it's also a pyramid because I have the apex here, where all of the triangles join and they have the same vertex up here. So this is a triangular pyramid. Now let's compare that to a different pyramid. Here, I can't choose my base anymore. I can't choose whichever one to be my base because I have a shape that is not a triangle here. So that one must be my base. And because my base is a square, this is a square pyramid. I see also that my lateral faces are triangles and they all join together at the apex again, up here at the top. So this square pyramid, we know that it's a square pyramid because the base is a square. Let's take a look at one more pyramid here. Let's take a look at it. Now let's look at the base. What kind of pyramid is this? How many sides? 1, 2, 3, 4, 5. 5 sides is a pentagon. So this must be a pentagonal pyramid. So as long as I have a polygon as the base, whatever that polygon is, that's how I'm going to name my pyramid. If my base is a pentagon like this, then it's a pentagonal pyramid. And again, as with all pyramids, my lateral faces are triangles and they all join together at the apex at the very top. All right, so that's it for pyramids. Let's take a look at a cone. So remember that a cone is a pyramid with the base as a circle now, which isn't really a pyramid anymore. Don't ever call a cone a pyramid because your math teacher will get mad. So this cone here, our base is a circle. We still have the apex here at the top where it joins into a corner here, a little point. And we don't have any more lateral faces. We only have the lateral surface. It's all around, doesn't have any edges. So it's just a surface, a lateral surface. All right, let's go back to the lesson and finish this up. Awesome work, sir. Our last group of shapes that we're going to talk about are the spheres. So the sphere is this ball-like shape which has similar properties to a circle. Let's take a look. The radius, so spheres have radii just like circles do. The radius of a sphere is a line from the center of the sphere to any points on the surface of the sphere. So this green dot represents the center of my sphere, and we have these red lines, my radii, coming from that center to points that are on the body of the sphere itself. So that's what the radius of a sphere means. The great circle is not just the name of a fancy circle. The great circle is a ring that goes around the diameter of a sphere, aka the widest part. So this purple ring here is a great circle because it's at the diameter of the sphere, it's at the widest part of the sphere. Finally, a sphere can be cut along the diameter, along the great circle, to create a hemisphere. And this hemisphere is exactly half of a sphere. So if you have a sphere, you cut that in half, you end up with a hemisphere. Let's check out what Mr. Garcia has for us now. And so the last shape that we're going to talk about is a sphere. Any kind of ball shape is a sphere. In this case, I got my basketball here. I hoop. I'm not better than you. I probably lose. So when I have a sphere, like we were talking about the properties of the sphere, we can also see that the basketball marks perfectly where our great circle is. So if I start from here and I go along this line all the way across, it shows me where my diameter is, which is also where my great circle is at. And basketballs also have another line going this way vertically now, like that. That is also a great circle because it's at the widest part of the basketball. And so now that I know where the great circle is, if I were to cut this ball in half along the great circle, along its diameter, then I would have a hemisphere. But I don't want to do that because I love this basketball and I'm probably going to go hoop later. So if I were to cut this though, I would have a hemisphere. All right. So that takes care of all of our shapes. I hope this lesson helped you out. I hope you understood it. If you have questions, like I said, please feel free to reach me out. Check out Miss Cattey's video if you need more help too. And check our assignments. Make sure you're up to date. All right. So take care, guys, and I'll see y'all later.